Okay, thanks, Howard. I want to thank everybody for having me here. This is great. For me, a big change is that I just retired, and I've been fighting to hold on to all of my equipment here at the university, and I've been able to do that. So I'm an emeritus now, and that's just a title. It means that I get to keep the lab, I get to keep my computer, the camera, and all that kind of stuff. Howard is right about the Viking Ranger. Some people argue it's the most beautiful transmitter ever made. Of course, we could go on and on about that. But it certainly was the AM rig to have during the 1950s. And here in the picture you can see what it looks like as I got mine, and then this is what it looks like completely restored. And it's not just physical restoration, it's also electrical. Okay. The first thing I should answer is how I got this thing. I was on an 80 meter CW QSO in November 2013. And I mentioned that I was using a homemade tube rig, and W3PH on the other end said, hey, if you work with tube gear, would you like to have a Ranger? I said, well, yeah, okay. And 2 days later, he brought it into the kitchen, and it was a little dirtier than you see it down here at the lower left. I've cleaned it up just a little bit, but it was all there. The cabinet was there and everything, and I offered him some money for it. He said, no, he said, I just wanted to give it to somebody that would probably be able to fix it up. And I said, well, thank you very much. And I spent the next 6 months working on this particular radio. Here it is unrestored, and it's got a lot of problems I'll talk about. Here's what it looks like after it's been restored. Howard, you can see that beautiful green that you talked about there. But that is actually a reproduction dial that I was able to buy, and I will be talking about that. It had obvious problems. You can see it here in all of its glory. One thing, I don't know what was going on, but the center section of the frequency scale was cut out. You can see it's cut out here. Maybe because the pointer was rubbing or something like that. I don't know, but it was cut out. There were globs of glue on that and so forth. The crystal cover was missing. Howard, does yours have the crystal cover? Okay, well, put the crystal cover in a safety deposit box because many of them are missing that because it pops out and people lose it, okay? The white pointers that are supposed to go in all of these knobs so you can tell how the knob is set, they're all missing. The cabinet, which you can't see here, was peeling, rusting. It was absolutely horrible. And inside, electrically, there were obvious electrical problems. R35 is this big resistor that it's very important. It was not there. There was this jumble of wires and little resistors that someone had tried to put in. And then there was the drive control down here at lower left was very rough, and it was obviously in need of replacement. That was just the stuff that's obvious, okay? So you have to deal with all that. But the first thing you want to do, and this is true in general, for any boat anchor, I like to call them vintage radios, the absolute thing you do not do is you do not plug it in and you don't even turn it on. Don't do that. Unless the place you got it from says, well, I was just using it last week and it's fine. Do not plug it in and do not turn it on until you've checked it out. You can vacuum out dirt. In mine, it had mouse bedding in it, so it was filled with sawdust. Fortunately, they hadn't eaten any of the wires and stuff. And just do a cursory cleaning. You don't want to do a really fancy cleaning until you know if the thing's going to work, okay? You want to remove and test the tubes. I'll talk a little bit about that. And when you take out the tubes, if there are several of the same kind of tube, be sure to keep track of which socket the tube came out of. Sometimes it makes a difference which socket a tube is in. Sometimes alignment can be critical, and switching identical tubes can cause problems. So keep track of where you pull them from. This is true in general. When you test tubes, the best way is to replace the tube with a new one. Of course, you probably haven't got one, but that's the best way. For transmitting tubes, about the only way to really check a transmitting tube is to replace it with a known good tube, because even in a tube tester, they're not put under load. You really can't tell. What I do with all of my classic gear is I acquire or buy backup tubes for all of it and keep it separated in Ziploc bags, so if I run into a problem I can just stick one in. But at this point you're probably going to use a tube tester. And there's two kinds out there. The emission tester, that's the most common one. An emission tester will tell you if it's a totally blown or bad tube, but the filament's completely wiped out. The emission tester will tell you that. But a lot of times an emission tester will show a tube as being bad when it really isn't. If an emission tester says it's okay and it's not shorted, well, maybe it is. But if it says it's bad, there's a good chance that it's still okay. The best way is to use the dynamic mutual conductance testers. These are far rarer and very expensive. I was able to find this almost new Hickok tester. If you have one of these, guard it with your life because these are just wonderful. They actually make the tube amplify and actually give you a good idea if the tube works or not. So you want to actually try and test the tubes, and if obviously one of them is completely dead or really shows, if it shows shorts, you got to be careful there. You're probably going to have to get a new tube. Initial electrical testing. As I say, you don't just plug it in and turn it on and pray. That's not the way that you do it. You want to leave the tubes out, and you want to pull out the pilot lamps too if you can, but that's not as critical. You want to remove any load from the transformers, what you want to try and do here. Get a hold of the schematic. And for all you folks out there, I have a Ranger website out there. It's at greglatta.com. Go to the ham radio page. There's a Johnson link, and there's a restoration page, and there's all kinds of stuff there, including a page on manuals, old advertisements, and so forth. Get the manual, print it out, and start reading it. You're going to need the schematic, okay? And what you want to do is take your ohm meter and test the primary circuit. You want to test continuity from each blade of the 120 volt plug through the circuit, inside, through the fuse, up to the transformer, through the on-off switch or the function switch, and so on and so forth, and make sure that there's continuity there, and make sure that there aren't any shorts or anything like that, okay? If you measure between a blade of the 110 plug and the chassis, there should be no resistance there, okay? You can also check the capacitors. The electrolytic capacitors can be checked. If you connect the ohm meter across them, the resistance should go down and then it should come back up. Now it won't come back all the way because the capacitor has resistance and most of them have a bleeder across them. But there's another little problem here that some of you may not know, and that is if you have one of the traditional ohm meters, like an old Lafayette meter or Olson meter or something, on most of the meters that aren't electronic and digital, the polarity of the ohm meter leads is flipped. The red is negative and the black is positive. So you can check this by hooking a diode up to the ohm meter, and if you hook the banded end of the diode to the black lead and the other end of the red, and if the resistance goes down, fine, they're like they should be. But if you have to connect the capacitor or the resistor backwards, so you have to connect the banded end to the positive lead and the other end of the negative lead, then the polarity of the ohm meter leads is switched. And when you check electrolytic capacitors, if that's the case, you put the negative lead on the positive end of the capacitor and the red lead on the negative end. Okay, otherwise it won't read right. You'll reverse polarize the capacitor and it won't work right. So you can check that. Okay, my meters are like that. Both of my analog meters are exactly like that. If something doesn't seem to check out, well then you got to track it down. You got to look at the schematic and figure out what's wrong. In mine, it's very common in a Ranger for the power switch. The contacts on the mode switch where the 120 volts goes through are often very worn and they may not work. In mine, I actually had to solder across them, and I just leave the thing on all the time and turn it off and on with a power strip that I plug it into. But check the initial thing. Safety, is so important here. I think most of our watchers out there are experienced, but for some people who have only worked with solid state equipment, boat anchors have high voltages in them, anywhere from several hundred to several thousands of volts. You have to be extremely careful. Even if it's turned off, it's not safe. There may be charge lingering on the electrolytics. You have to discharge that. And even if it's plugged in, there still may be AC at certain points. So you don't work on it until it's unplugged and turned off and you've discharged all of the capacitors. When you make measurements, preferably, though difficult, is the zero hands rule. If you're going to measure a voltage, you get clips on your voltmeter leads. You clip them across the device that you're going to measure. Then you turn the unit on, make the measurement, turn it off, and remove the clip. So you never have a hand on a test probe when you're measuring a voltage. That's often not convenient, and so then you use the one-hand rule. Usually in this case, you're going to connect one clip to ground. And then you take one hand and you put it in your pocket and you use the other hand to make the measurement, so that you never have two hands simultaneously on the voltmeter probes. That's not a good thing to do. That's a recipe for electrocution. Okay. The transformer is the single, just about irreplaceable component in any of these classic radios. For instance, the transformer in the this rig has got 6 different taps on the secondary. Very hard to replace that if it's bad. It probably is fine, but you want to check it out. And the way to do this is if you've got a variac is one of these variable AC outlets. You can dial the voltage on the plug on it, anywhere from 0 to 140% of full power. If you haven't got one, no problem. I'll show you how you can take care of that. But what you want to do is take the variac and you set it so that the socket is 12 volts AC, about 10% of normal line voltage. That's what you want. You make sure that the tubes aren't plugged in and so forth. And again, the pilot lights aren't plugged in. And here's a tricky: make sure that the high voltage transformer secondary is truly disconnected. You say, well, isn't it disconnected if all the rectifier tubes are out? Well, not necessarily, because someone may have modified it and put in solid state diodes and soldered them under the chassis, and so it may be still connected to the filter capacitors and bleeders and all of that. If that's the case, you got to make sure that that secondary is disconnected. You may have to unsolder it. Never, ever, ever cut a transformer lead. Never cut a transformer lead. They're always going to be too short. You want to try and unsolder them, okay? And the idea is, once you get everything disconnected from the transformer, you plug it in, you plug the rig into the variac, you turn it on, and you measure all the secondary voltages. And you watch, and you smell, and you listen for any weirdness going on. Now, there probably won't be anything at this point. With 10% line voltage, you're probably not going to have a problem. But smell very carefully. The 6-volt filament secondary, well, it should be 0.6 volts, 1/10 of normal. The 500 volt or whatever it is, high voltage secondary should be 50 volts, and so forth. They will probably be high because it's not loaded. That's kind of okay. But if one of them is very low, you're going to have to go look for a short or something weird going on. Because if you were to power it all the way up, you could risk burning out the transformer. And you definitely don't want to do that. And this again is true for any kind of a classic rig that's been sitting and in its unknown condition. You want to check it out thoroughly before you just dive in there and go with it. If you haven't got a variac, well, you can use a filament transformer. Most hams who work in this kind of stuff have got like a 6 or a 12 volt or maybe a 24 volt filament transformer there. You can hook the line cord up to that, and so you're running it at a very small percentage of full power. Or, I actually did this, you can put a 10K 2-watt resistor in series with the AC cord. This allows just enough current to get into the transformer, provided it's not loaded, for you to make this test. Then you measure the voltage across the transformer primary. And then when you go and check the voltage on all the secondaries, you want to see that they're the correct percent of their normal values. If you've got 10 volts across the transformer primary, then you should have 10 120ths, whatever that is, of the voltage across all the secondaries. Okay, it's better if you got a variac, but this will work. Okay, just get yourself a 10K 2-watt resistor, and that'll work fine. And if it's a 12K or 15K, oh heck, that's going to work too. All right, but check it all out. You got a low voltage. Make sure that the high voltage secondary is truly disconnected. Filament secondary voltage is really low. You could have a piece of solder stuck in there. Who knows, a mouse could have drawn in a piece of wire and wedged it in between the filament pins on a tube socket. You never know, but you have to resolve this before you continue. You gotta resolve these issues before you truly smoke test it. Okay, this is true again for any radio. Okay, finally, you have to do the final test. Is if you have the variac, you bring it up to 20%, 30%, 40%, 50%, checking as you go, smelling, listening, and watching as you go until you can get it up to 100%. Now there's a problem. If you've got a variac, a lot of these will go to 140 volts. And you obviously don't want to do that. You don't want to exceed 100%. Mine is wired up so it goes from 0 to 100 on the scale, and I can't over voltage the thing. But just be aware. If you haven't got a variac and you use the other method, all you can really do at this point is plug it in and turn it on and very quickly listen and watch and make sure nothing bad happens. Okay, you haven't really got any other option there. Okay. If you get this far, then what you can do in the Ranger is you can plug in all of the tubes except the 3 rectifiers. There are 2 big rectifiers, the 5R4 and the 6AX5, and then a lot of people don't know this. There's a little rectifier tube, a little tiny 9-pin tube or 7-pin tube, I think it's 9-pin tube, on that little aluminum tray that's attached to the front panel. There are 2 tubes on that. That's the keying circuit. And there's a 6AL5 there. Don't plug that one in, okay? Make sure, again, the secondary on the high voltage is disconnected. And in the back, this blew me the first time I did it, pins 7 and 8 on that back connector, that 9-pin connector, must be connected. If not, some of the tubes don't get filament voltage, and they won't light up. When I first did it, I said, oh, I got a problem. Half of these tubes aren't lighting. And I looked at the schematic. Oh, okay. You got to have that 9-pin connector plugged in the back. Plug it in, turn it on with 120 volts in, check all the tubes, and make sure that they light. If you have metal modulator tubes, those are the 6L6s or the 1614s, you just got to have to feel them to see if they start to get a little bit warm after a while. Okay, so you can't see them. If you've got regular glass 6L6s, you can look inside and see if they light up. And if all the tubes are lighting, well, that's another step forward in progress. Okay. Next thing is you got to check the electrolytic capacitors. Ultimately, you're probably going to want to, at some point, replace all of the electrolytic capacitors in the transmitter. This is called recapping the transmitter. I'll talk about this. But in particular, there are several that you want to check before you plug in the rectifier tubes. There's a big one, which is C77. That's supposed to be 10 microfarad at like 700 volts. There's a 450 volt capacitor, and then there are a couple of little capacitors, C90A and B, and you probably won't see them because they are underneath that little metal bracket where the 6AL5 plugs in. That little metal bracket sitting there. There's 2 screws you can take out, and you can pull that up and see the bottom of it, and you can check those, okay? Again, you can check them with the capacitor checker if you got it, or with an ohm meter, paying attention to polarity on the ohm meter if it's reversed. And if these don't check out okay, you got to replace them. Okay, you have to replace them. Now the trouble is, some of these you can't buy anymore, and I'll talk about that. But if necessary, you can replace C78 with a bigger unit, 47 mics at 450, and you can also replace C90 A and B with a single 30 microfarad unit. These two are in parallel, so they really are a 30 microfarad unit, and they're only about 50 volts. But it turns out if you buy 150 volt units, it's cheaper. Why did the people at Johnson put 2 capacitors in parallel? My answer is they probably had a whole bunch of them in their factory and decided to use them to keep the cost down. But you replace that one if you have to, okay? The big one is a problem. If it's not okay, you cannot get a 10 microfarad unit at 700 volts. So what you do is you buy 2 33 microfarad 450 volt units, and you put them in series, and you bridge each one of these with the 270 ohm 3 watt equalizing resistor. These are bleeder resistors too, but the purpose of these resistors is to equalize the voltage across these and make sure they share equally the B plus voltage. You can see how I mounted them here. Do not use carbon resistors for the bleeder resistors. Carbon resistors, when they get hot, the resistance can go down with age. They get hotter, the resistance goes down, they run away, and they burn out. So you should never use carbon resistors for bleeder resistors. They're not a good thing. To mount this, if you have to, and eventually you're going to want to replace it, here's how I did it. I made 2 standoffs here. It's hard to see here. They're made out of 1/4-inch aluminum. I made them in my machine shop. And then I mount 2 of the terminal strips on the edges here, and I mount the capacitors and the new resistors there. Eventually, you're going to want to do this. But if it measures okay for the moment, leave it alone, and you can at least test the unit out like that. Okay. In general, though, you're going to want to replace all of the electrolytic capacitors in this transmitter, and this is pretty much true for about any vintage radio. The problem is that these things contain a paste or a liquid electrolyte which dries out over the years. A lot of it can dry out and the capacitor will still work fine. And so you say, great, I don't have to replace it. But after you start using the unit and putting those capacitors back into that heat environment, the heat from using it tends to dry out whatever's left, and it eventually will probably go anyway. We're talking about a unit here that's 60 years old, and so I think you should eventually replace all of them. Now, here's something I spent a couple hours doing for all you folks out there. Go to my website and go to my ham radio website and go to the Johnson Viking Ranger site, and there's a link to restoration. And I put together a chart, a table of all the parts you can still buy from places like Mouser Electronics and Antique Electronic Supply and Radio Days, with the actual links to the part so that you can get those parts. So these electrolytic capacitor links are there, the resistor link for that big resistor is there. You check that out. Many of these parts are still available out there, okay? Ultimately, you're going to replace all the electrolytics. For filter capacitors, you can use a slightly higher capacitance, and a higher voltage is fine. But for audio capacitors, like there's 2 of them in the audio stages, don't change the capacitance. Don't increase the capacitance, because it'll change the frequency response. Okay? That's a case where it's not really okay to use a bigger capacitor. You could unintentionally alter the audio characteristics of the Ranger, but you can use higher voltage capacitors all the time. All right? Good old R35, okay? R35, you can see it in the picture over here, is this big, huge 20 or 50 watt power resistor. In mine, it was gone. It wasn't even there. Okay, it wasn't even there. But I was able to find it online. It's easy enough to buy. It's 20 bucks, and you can buy it. The link to it is in there. Is in the list that I give, and even the mounting parts for it are there too. The replacement one that I got here 60 years later fit perfectly. It's a crucial part. It's a bleeder for the high B+, it's a voltage divider for the modulator and clamper tube screens. What that means is it's critical in both the CW and AM modes. Okay, you got to fix this before you really try and do anything with the rig if it's not okay. If everything is all right, when you get everything up and the voltage regulator or the tubes all in it, including the rectifier tubes, the voltage on the tap should be about 250 volts in AM mode. But the reason that this thing gives problem is not because it burns out. It's because people like you and me abuse it. Okay? This slider allows you to adjust the voltage here on the screen grids of the modulator. You do not tighten this screw all the way down. If you do that, you will press the little dimple on it here into the delicate windings and you will break the windings. Also, if you move this, you must loosen this screw completely so that this little dimple does not rub at all. If you try and force this up and down, you will break one of the wires and you've got to replace the part. Okay, 20 bucks isn't so bad, but you don't want to have to replace it. Okay, people abuse this, and that's why it's often broken. Okay, if you don't mess around with it when you put it on here, you just tighten this screw just enough for a secure fit. It only has to supply a few milliamps so it doesn't jump around and jiggle and so forth, and that's all that you want to do with it. Okay, which brings us to the final smoke test. If things have checked out at this point, then you're at a point where you can plug in all the tubes, including the rectifier tubes. If you got a variac, turn it down, plug it in, and gradually bring it up to full, smelling and listening for any problems. No variac, then it's literally a smoke test. You plug it in, quickly turn it on, and you watch for anything or smell or listen for anything hissing, and hopefully nothing will happen. It didn't happen with mine. Okay. Now here's something that might scare you. All right, Howard, you might notice this on yours. The design of this radio, the metering circuit, and the clamper circuit is such that if you put the meter control in the plate current position, even though the key is up or the mic is not in push to talk, it's not in transmit mode, you will see about 50 milliamps of plate current showing on the meter. This does not mean that there is a problem. This is normal. It's normal for the clamper circuit to draw about 20 milliamps of current in the key up mode. It's normal for the 6146 to draw about 30 milliamps when it's in standby mode. It's not keyed. The final amplifier tube is not keyed in this transmitter. Instead, a clamper tube is used, so that 50 milliamps is okay. All right. Again, though, watch, smell, and listen for any problems. And if you get this far, okay, you've made it through a major hurdle. What you need to do at this point, people, is read the manual. Read the manual. Treat this as a brand new radio. You want to hook it up to a dummy load. You want to try and operate it and see how it behaves and see if it has problems. If it does, that's beyond the scope of this talk. Okay, you'll have to just start to work things out on your own. Okay, for the cosmetic things, cosmetically, for painting the cabinet, mine was horrible. Mine had this wretched blue flaking paint all over it, and it was rusted in spots. I use strip ease to strip off the paint. If you use a paint stripper, use rubber gloves, the proper type, nitrile rubber gloves, not latex gloves. The paint stripper will eat them. Don't get paint stripper on your hands, but strip off the paint, and then you scrub it down with steel wool until it's absolutely bare metal. And then I primed it with Rust-Oleum metal primer, and then I mixed 2 parts of gloss black Rust-Oleum to 1 part of white Rust-Oleum, and that gave me what I thought was an attractive shade of gray. Now, it wasn't originally gray. It was, if you find an original picture of it, it's some color that I don't think you'll ever duplicate. So I tried to come up with a gray that matched the color of the front panel. And as you can see, it turned out pretty well, okay? I use an airbrush to do all of my painting. And Howard, maybe I can do a program sometime on how to airbrush equipment like this. Once you use an airbrush to do painting on electronic equipment, you will never touch a spray can or a paintbrush again in your life. You get an airbrush set up, doesn't cost too much, less than a couple $100 even with the compressor. It's just the way to go. I do have a video on my YouTube channel. Just go to Greg Latta on YouTube. Under the Science and Technology playlist, you can see I show a little bit about my airbrush setup, but I don't really show you how to airbrush. But you can see how it turned out. It's pretty nice. And I want you to notice something else about this radio. Here on the back, this is a problem. Let me move my pointer here. If you try and put anything on the back panel of the chassis, it has to fit within these 2 rectangular areas. And that can turn out to be a problem. You're going to see here, that's a problem when you try and add a fuse to this. This shows the replacement line cord that I put on this and the new line cord restraint. This is a modification that you should do. In general, you should avoid modifying a radio like this. You don't get a fine piece of colonial furniture and start playing around with it. You've got an antique here, you should respect it as that, and a lot of the modifications you'll see, particularly to the audio section, are rubbish. The audio section is fine in it, but this is one that you need to do. You need to put in a grounded 3-conductor cord to make this thing safe. And you'll also need a strain relief for that cord. This thing doesn't draw much current, maybe 5 amps, and so an 18.3 grounded line cord is fine. I have a link to on my website that shows this part at Mouser, the one that I used, but you can get an old computer cord, cut the end off of it and use that. You'll also need a strain relief. That can be a problem, okay? If you have to enlarge the cord hole to make the strain relief fit, be careful. Be careful. It's really easy to lose control of that and have that drill accidentally go in, and then you just chewed up a bunch of parts. So you got to be really, really careful with that. For the fuse, you cannot use the traditional single hole mounting fuse holder. It won't fit on the back panel within those rectangular areas. If you find a place on the outside, on the inside it runs into parts, so you can't do it. Instead, you use a molded fuse block. You can see here in the picture, it's up here, it's a little black fuse box. There's just enough room to squeeze it in between the accessory, or the plug and the back panel. One screw holds it in place. You can see here's the new cord over here with the leads coming out and going over to the fuse. Yes, the fuse is inside the unit so that if it blows you have to pull the cabinet off. But you know what, if the fuse blows, you probably want to pull the cabinet off and check out what's going on anyway. It's inconvenient, but that's the only way I could figure out how to do it. Okay? Now, Howard mentioned the VFO, okay? My opinion is that I don't care if it's a brand new VFO, it's going to drift too much after repair. Drift defined nowadays and drift defined back in 1955 are two different things. What was low drift or stable in 1955 is not acceptable nowadays. Even when this bugger is brand new, I replaced all of the capacitors in mine, but there's a problem with the temperature compensating. It still jumped around, it still drifted, and temperature compensation shouldn't be used really for any of these classic radios. You can't take a VFO, stick it inside a radio with two modulator tubes, two rectifier tubes, and a final surrounding it and expect it to be stable. Instead, use crystal control or get or build a digital VFO. Howard, maybe this is one of the things we can talk about in a future thing here on this forum. This is a digital VFO that I use with all of my classic rigs. It drives my DX40, it'll drive a DX60, it drives my ICO, it drives the Ranger, it's driven every rig that I have hooked it up to, and it just simply solves the problem. Question is, how do you get the signal in? Easy. You feed it in through the Crystal 1 input. This is a couple of pins on the crystal socket on the front of the radio. You go to Antique Electronic Supply, this is in that parts list I mentioned, and you get this plug. It's a little bit bigger than a CPVC plumbing fitting, a coupling that you can buy at Lowe's or Home Improvement or whatever, okay? You sand this down just a little bit, it'll snap in there, and you can don't glue it, but it'll go in there. And I used a couple of tiny screws just to secure it. Why? Because if you pull it out and it sticks in the crystal socket, you're going to have a devil of a time getting out. So I use little screws here to hold it. But what you do is you run a wire from pin 3 of the socket, the crystal socket, to the ground on an RCA connector that you mount on the other end, and then you use a .001 or 01 capacitor in series with pin 5 to the middle of the RCA. And then you can see you just plug the VFO into the crystal socket. If your crystal cover is missing, it solves that problem at the same time. Now, also, if you go to my website on the VFO page, and I also have a movie about this as well. There's a video on my YouTube site. If you go there, you can build a 2-to-1 voltage step-up toroid that'll double the output of your VFO. And if your VFO isn't driving your classic rig and you just add this one capacitor and this one little toroid, the chances are it will drive it. I actually put this toroid inside this little coupling so that the 2-to-1 transformer up is present there too. Okay, and all the instructions for making that VFO are on my website. Look at my website, and all the instructions are there. We're almost done. Chassis cleaning. Okay, chassis cleaning. I use naphtha, which is lighter fluid, and Q-tips, and I literally scrub the whole thing down to get all of the garbage off of it. Okay, it's like scrubbing the floor of a stadium with a toothbrush. It takes time, but it will pay off in the end. Don't use alcohol, acetone, and absolutely never use lacquer thinner. Lacquer thinner is an explosive, and you never use it unless you're outside or unless you know what you're doing with it. And you never apply the solvent directly to the chassis or anything. I use Pledge to wax the chassis when I'm finished with it. If you do that, the dust will come off easier when you go future cleaning. Waxing the chassis with Pledge will make the dust come off easier, but you don't spray the Pledge onto the chassis, you spray it onto the rag and then you rub the rag onto the chassis. Or you take a rag with a little bit of naphtha on it and you rub it on the chassis. I will also clean off the white parts of the of the capacitors, the variable capacitors and so forth, with the naphtha and so on and so forth. It works just great, okay? But it takes a while. And once that's done, let's see if I can show you. Here's what the chassis looks like under mine right now. You can see all the dirt's gone. The capacitors have been replaced. Here's the B plus capacitors. Here's C78 down here. Here are the two electrolytic capacitors that are in the audio section, and everything is clean almost the day that they made it. And while I'm here, I can also mention, if you want to know whether your Ranger was a kit or whether it was manufactured at the factory, if the tube sockets and stuff are riveted, then it was made at the factory. If everything is fastened with screws and nuts, then it was made by somebody else, okay? So that's one way to help that out. I also used an airbrush, and after taking hours to mask off the chassis and everything, masking everything off except the transformers, you can see they're rusty here. I airbrushed these with rusty metal primer, sprayed them with double black, gloss black, and you can see the difference it made. And then I turned it on and let it idle for a day, and the heat from the transformers made it rock hard. Again, I used an airbrush that let me get right down into the nooks and crannies here, and not even spray the down inside there below the feet with extra paint. It worked out great. For the knobs, I take these, you remove the set screws, don't lose them, and then watch out you don't lose a little white insert if it's there. I scrub these with a toothbrush and soft scrub, okay? Soft scrub is used, it's a very mild abrasive that's available for the kitchen, and you scrub it with a toothbrush, and then you spray it down with Pledge and polish it up, and it looks almost brand new. But don't lose that pointer if you got it. If you do, there is a part, it's kind of expensive, that you can buy that a reader of my webpage sent me, and a link to that is on my webpage. But I just got acetoplastic and turned it down to 1/8 inch on the lathe, and then I just cut a piece off and then just put it in and shove it in with the plier, and the result is it looks like that, okay? But God bless you if you got those, okay? And you can scrub those down too, but don't lose them, okay? Don't lose them. Here's a mystery, here's a mystery. I've gotten people write me on my webpage saying, how the heck do I replace the lights that light the bezel? How do you get to the pilot lamps that are underneath this front bezel? Okay, how do you get that bezel off? Okay, well, what you have to do is, one, you remove the two knobs and the main tuning knob, and then from behind, if you look here, right in front of the pilot light that lights the bezel, there is a hex nut there. There's a little hex nut. It's kind of hard to see there. And there are two of these jewels, as I call them. There's also one on the other side. You can't see it here. But you can take the screws out that hold this little shelf in here. By the way, if this shelf is missing, you've got a 54, one of the very first Rangers. The very first Rangers didn't have this circuit. Take these two screws out, and you can get these tubes out of the way. You can undo that hex bezel, and then further down where you can't see it here, there is a hex nut on a screw you have to undo. So there are four things holding that bezel on. And once you get all of them out, you can take the bezel off and clean the front panel and replace those lights if you have to, okay? And what I then did was I took clear coat, here's one of my secrets here, clear coat auto polishing compound. Go to your auto store, This is the polishing compound that's used to polish these cherry red orange and these motorcycle finishes that are high gloss. It's an extremely fine polishing compound. It's called clear coat polishing compound. You can rub it down with that, and that will clean off the patina, but it should not affect the paint that is on there. It's very, very, very fine stuff. If you're not sure, try a little portion, see how it works, and then work yourself all the way around. Get rid of all traces, and then I use Pledge to wax the whole panel, and the result is what you see here on the right. All right, the frequency scale. Look at how ugly this thing was. Okay, they cut out the plastic, and there are globs of glue. I think it's super glue. I don't know how it got there, but to clean this, you remove the bezel like I just showed you, and then I used Q-tips and lighter fluid. I tested it. It didn't affect the paint. If yours is okay, don't use a lighter fluid, but you can clean and polish this thing with that clear coat compound. It should not affect the paint on either side. It shouldn't affect it on either side, okay? And on mine, because of the light piping effect, I used flat black paint to paint this inner edge where they had cut it out, and that got rid of the light that was piping through, and the result of that was this. And you can't even see that the inner part is missing. But here's the really good news, that I think they're still in business. It is possible to get a brand new frequency scale from a place called radiodays.com. It's about $40, but the link to it is on my website there. I eventually put that in, and you can see what the Ranger looks like when it's fully restored. All right, and with that, I'm done.